Hello everyone. So today let's start with the next topics, that is physical and chemical properties of alcohols. First of all, we will see physical properties. Okay, if you see the physical properties, the alcohols, the lower member of alcohols like methanol or ethanol or propanol or isopropyl alcohol, anyone. These lower members are colorless, volatile, that means they evaporate. They are highly volatile. These alcohols are highly volatile. They evaporate very fast. And they have an alcoholic color, like alcoholic smell, and burning taste. That means if you put it on some on a tongue, it will have some burning taste. Okay, these lower members are soluble in water also. Okay. And its consumption weakens. Its consumption weakens the central nervous system. That means if you somewhere you see, if some person consumes alcohol, he or she remains unconscious or doesn't remember anything like that if you have experienced. Okay, next we will see the boiling point. If you compare the boiling point, if you see in the haloalkanes and haloarenes, we know that we have compared that boiling point directly proportional to molecular mass. If the molecular mass is higher, the boiling point will be higher. But if we compare an alkane and alkyl halide with that of the alcohol having similar molecular mass, the boiling point of the alcohol will be much greater than as compared to that alkyl halide or alkane, because in alcohols there is intermolecular hydrogen bonding. Intermolecular, that means within molecules there are hydrogen bonding. Due to this intermolecular hydrogen bonding between ROH and O, intermolecular hydrogen bonding, the molecules are bonded comparatively more stronger as compared to other alkyl halides or alkanes. That's why their boiling point is comparatively more higher. Then if you see solubility in water, the lower members of alcohols, they are highly soluble in water, easily soluble because they form hydrogen bonding with water. As they form hydrogen bonding with water, they are highly soluble in water. And if you see, if the molecular mass of the alcohol increases continuously, if you increase the molecular mass, the solubility in the water will be decreasing. Okay. Next, we will see the chemical reaction in alcohols. Okay. First of all, if you see the properties of alcohols or the chemical reactions or chemical properties, we can also say chemical reactions or chemical properties. The alcohol is acidic in nature. Alcohol is acidic in nature. Acid is a thing which releases H plus ion. If then alcohol ROH releases H plus ion and forms alkoxide ion plus H plus, then it is an acid. Okay. If there is plus I substituent attached to the alcohol, then it decreases the acidity or it increases electron density. If it increases the electron density, this hydrogen or H plus will not be easily removed. If plus I group attached, it will not be easily removed, hence the acidity decreases. Plus I group increases, acidity decreases. Okay. And if we compare the strength of acidity in case of alcohol, alcohol is an weaker acid, than water, but a stronger acid than acetylene or ethylene. C triple bond H. Oh, so C triple bond CH. How do you know this acetylene is acidic? Because when you react acetylene with alkali metal sodium, it gives C minus Na plus half H2. Similar to this reaction, when the alcohol is also reacted with alkali metals, this also produces hydrogen gas. There is the property of a acid is that when acid reacts with metal, it produces hydrogen gas. We previously done the experiments in the lower classes, like if you put some zinc granules in hydrochloric acid or sulfuric acid, it produces hydrogen gas. If you put a matchstick above the gas, it produces popcorn. That is the presence of hydrogen gas. Similar to that of the acids, alcohol when reacted with alkali metals like sodium or alkaline earth metals like magnesium, this produces alkoxide ion and half molecule of hydrogen gas. This due to this production of hydrogen gas, the alcohol is little bit acidic. It is weak acid, it is weaker acid than water, but stronger acid than acetylene. If we compare the acidic strength of primary, secondary and tertiary alcohols, the acidic strength of primary alcohol is the highest, then the secondary alcohol, then the tertiary alcohol, because in the tertiary alcohol to the carbon there are already 3 R groups that are attached to the carbon. These R groups increases plus I effect, and if the plus I effect increases, acidity decreases. Hence tertiary is the least acidic, primary is the most acidic. Above primary also there is one more most acidic, which we can say, we can also write 1 degree, that of the methanol. This is the most acidic. Okay. Next, if you see the reaction of alcohol with that of the hydrate, metal hydrate. In metal hydrate, if you compare this metal hydrate, sodium Na plus and this one H minus, this H minus deprotonates the proton of alcohol and form hydrogen gas, and this forms sodium alkoxide. Okay. Next in the reaction we will see esterification reaction or ester formation reaction. Okay. The esterification reaction or esterification reaction when an carboxylic acid, this is carboxylic acid, reacts with alcohol in presence of acid, we can write H2SO4 or simply we can write H plus. In presence of acid to produce an ester. This is the ester linkage. Like if we see R, C double bond O, O R dash. This is ester linkage. COO produces ester with water. Next we will see the mechanism of esterification. So first of all start with carboxylic acid. OH. This OH is not a good living group. Okay. First, when it reacts with proton, this OH group protonates and it forms RC double bond O OH2 plus. Now this OH2 plus, this is a good living group. Leaves as water. This leaves as water, and there is formation of carbocation. Then the alcohol group, if you see R dash OH, this reacts as a nucleophile. These oxygen have lone pairs, the lone pairs attack here. Okay. Then there is formation of RC double bond O O R dash H. As this oxygen gives the electron, so it becomes plus. Now this OH loses one proton, minus H plus, to produce R C double bond O O R dash. This is respective ester. Okay. And this is the catalyst H plus that is used as catalyst. As the catalyst is used in reaction and it is leaving the reaction in the same amount as same as the catalyst. Okay. Next we will see the rate of esterification. The rate of esterification is highest in case of methanol, then primary, then secondary, then tertiary. Okay. This is because as the bulkiness increases, bulkiness in the alcohol group increases, the rate of esterification decreases. As the bulkiness increases, this nucleophile cannot approach here, more bulkier cannot approach easily, hence the rate of the reaction decreases. Bulkiness increases, rate of the reaction or rate of esterification decreases. Okay. Then we will see the reaction of alcohol with acid chlorides, or we can say acid chlorides are otherwise known as acid chlorides. Okay. The reaction is same as the esterification reaction, but instead of carboxylic acid we are using acid chloride or acid chloride. We will see the mechanism, and in the product there is formation of ester. We will see the mechanism. First of all, in this reaction, this is pyridine used as a catalyst. This pyridine acts as a base and it deprotonates the alcohol. Let us consider if this is R-OH. This is alcohol. This is little bit acidic proton. So first of all, this reacts with pyridine. Let me make the structure of pyridine. This reacts with pyridine, and pyridine first of all extract the proton, and there is formation of R-O minus. This now acts as a nucleophile. Okay. This nucleophile will now react with the acid chloride. Let us consider the acid chloride R C double bond O Cl. Now the nucleophile, which is nucleophile O minus R dash. This will now attack to the carbonyl carbon. R O minus, there is Cl and there is O R dash. Now this Cl group, that is a good leaving group. This Cl is a good leaving group. So this negative charge will come back. This will be removed as Cl minus, and there is formation of R C double bond O O R dash. This is ester. So when acid chloride reacts with alcohol in presence of a base like pyridine, it forms ester along with Cl. The side product is HCl. This now this Cl minus that is produced, this takes off the H from the pyridine, and H plus. Now this takes the H and formation of HCl. Okay. Next we will see the reaction of hydrogen halides. Hydrogen halide, or we can say haloacids like HCl, HBr. When this reacts with this alcohol reacts with HCl in presence of anhydrous ZnCl2, there is formation of alkyl halide. We have seen this reaction in the method of preparation for alkyl halides. Alcohol reacts with HCl in presence of anhydrous ZnCl2 for the formation of alkyl halide. And this method is also used for test for alcohols. test for alcohols known as Lucas test. This test distinguishes between primary, secondary, tertiary alcohol. If we react this with a tertiary alcohol, there will be formation of cloudiness immediately, and if we react this with a secondary alcohol, the cloudiness or the precipitate will appear within 5 minutes, and for primary alcohol this will appear by heating. Okay, now we'll see how this reaction goes on and the mechanism. Okay, this is HCl. HCl, this means acid, so HCl will break down to form H plus plus Cl minus. Okay, now for the first step, let us consider this is primary alcohol. Okay, now this will ROH react with H plus, this OH will protonate. Now this will form R OH2 plus, and as this is primary alcohol, this is primary alcohol, if we can if we say this will go as minus H2O and this will form R plus, if this is primary, the primary carbocation is unstable. The primary carbocation is unstable. Hence, it will proceed through, instead of SN1 mechanism, there is formation of carbocation, it will proceed to SN2 reaction. Like this Cl minus will attack and this will go out, and there will be formation of, instead of carbocation, this will form RCl. And if there is, instead of primary alcohol, if there is tertiary alcohol like this, so this will first protonate, three methyl groups. Now this will lose water and there will be formation of tertiary carbocation. This tertiary carbocation is stable carbocation, so this will form. And this reaction generally goes through SN1 mechanism. Hence, the rate of the reaction is tertiary is the highest rate of reaction, then the secondary, then the primary, then the methyl. Okay, as this undergo like SN1 mechanism, so there is formation of carbocation. As the primary carbocation and the methyl carbocation are unstable or less stable, least stable as compared to tertiary, so the rate of the reaction is lowest in case of primary or methyl. And if we consider the different alkylating agents like HRI or RBr or RCl or RA, like if we consider like hydrogen iodide or hydrogen chloride, HCl or HI, the rate of the reaction will be highest in case of Ri, because this I is a good leaving group. Okay. Next, if there is formation of carbocation, then in the intermediate step, if there is formation of intermediate, this carbocation can undergo rearrangement to form more stable carbocation in the intermediate state, and there will be different product from the expected product. Like if you see, let us consider one reaction. Like if you see, okay, this is CH3, this is CH3, this is CH3. Now this will first undergo protonation and this will form, instead of CH3 I am writing methyl, OH2 plus, this is H, this is methyl, this is methyl, this is methyl. Now water will remove and there will be formation of carbocation. So this carbocation will form. Okay. Now if you see, this is secondary carbocation. But if we do one rearrangement, that is 1 to methyl shift, 1 to methyl shift, one methyl will be shifted from here to here, there will be formation of this carbocation is tertiary carbocation. So this is more stable. Like this situation, like similar conditions, there will be rearrangement when there is formation of more stable carbocation in the rearranged product. The intermediate will go on rearrangement and this will form more stable carbocation or more stable intermediate, and then the nucleophile like Cl minus will attack here. The product will be okay. And if you see, if the concentration of now let's go back to the, if the concentration of ZnCl2 is low, the reaction takes place by SN2 mechanism. That means if the concentration of ZnCl2 low, there is not more stable carbocation form. The reaction takes place will be, the reaction will be in SN2 mechanism. Or we can see, if you see the primary alcohols, the primary carbocation is least stable, or we can say it is unstable, so it will take place by SN2 mechanism. Similar to like that of the alkyl halides. Okay, no issues with that. Okay, next we will see the reaction with PCl5 and PCl3. We have already studied these reactions for the methods of preparation of alkyl halide. If you react with PCl3, there will be formation of alkyl halide or RCA along with H3PO3, and in case of OH react, alcohol reacting with PCl5, it will form POCl3 plus HCl. So there may be one confusion regarding this PCl3 and PCl5. Like you will be confused in which case there will be H3PO3, in which case there will be POCl3. The short trick, if you see the short trick behind this is PCl3 and this is PCl5. In PCl5 there is more chlorine. Which has more chlorine, this will produce POCl3, and the less chlorine will produce H3PO3. Like this you can remember, or otherwise if you can remember in your convenient way, that is all good. Okay. Next we will see reaction with thionyl chloride or SOCl2. This method is the best method for the preparation of alkyl halide. As we have seen, this produces and this undergoes through SN-I mechanism. We have seen the mechanism for the reaction also in the chapter of haloalkanes and halohalides. This react with the SOCl2 forming RCl, SO2 and HCl. These both are gases, so they are evaporated. This is the best method for the preparation of alkyl halides. Next we will see the acidic dehydration of alcohol, or generally we can say dehydration of alcohol with mechanism. Generally one concentrated acid like sulfuric acid is used for the dehydration of alcohol. Okay. Now we will see this. Let us consider this is as ethanol. Ethanol when treated with concentrated H2SO4, this forms ethene. Alcohol forms alkene along with one water. Dehydration, that means it releases one molecule of water. Now we will see the mechanism and different types of reactions where there will be formation of two products like minor and major product. In this reaction there will be formation of one product, but there are some reactions and there are formation of different types of product. Okay, we'll start with mechanism. CH3 CH2OH. This is ethanol. As is considered H2SO4, this H2SO4 will break to H plus plus HSO4 minus. Okay. Now this will react with proton. This OH will be protonated and there will be formation of CH3 CH2 OH2 plus. Now this is a good leaving group. So this will be removed and there will be formation of carbocation CH3 CH2 plus. If we write by separate bonds CH H. Now this carbocation will be unstable. Primary carbocation. Primary carbocation. So this is unstable. This will go some rearrangements. So in the next step, this is step 1. This is step 2. Step 1 is protonation. Step 2 is dehydration. Step 3. This is step 3. This is step 3. 1 HSO4 minus from H2SO4. This will attack to the hydrogen, and this hydrogen will give its electron to double bond. There will be formation of C double bond CH plus H2SO4. This is catalyst removed as it is, and this is formation of product. This step is step 3, and this is deprotonation. First step is protonation, addition of proton. The last step is deprotonation, removal of proton. Okay. As this goes through intermediate carbocation, this carbocation may also rearrange, and in this case there is formation of chances of formation of one product. You will see next where the chances of formation of different types of product, like here if you see this one. This is one type of beta elimination reaction, like this alpha carbon. This is beta carbon. From the alpha carbon the OH group is removed, from the beta carbon H group is removed. The group where there are two beta carbons, there is confusion, like which one will be the major product. Let us consider one such type of reaction. Let us see. CH3 CH2 CHOH CH3. Okay. If we react this with concentrated H2SO4, this will remove in the first step protonation and deprotonation. After protonation and dehydration, there will be formation of CH3 CH2 CH plus and CH3. This carbocation will form. If you write this splittingly by splitting, this is H. This is carbocation, and there are two chances, like two paths, path A and path B. If you consider, this proton may be removed and there will be formation of product like this, CH3 CH2 single bond CH double bond CH2. If this proceeds through path B, if this proceeds through path A and the proton is removed from this carbon, there will be formation of CH3 CH double bond CH single bond CH3. Now there are formation of two products, like product B and product A. Now the confusion arises, which one is the major product. So this product will be the major product. This product will be the major product according to Sedgwick rule. According to Sedgwick rule. And this Sedgwick rule is applicable in case of dehydration of alcohol and also in case of like beta elimination reaction. This Sedgwick rule states that when there is formation of two or more products, two or more alkenes, the more substituted alkene will be major product. If we compare these two, products, like first one is CH3 CH double bonds CH3. The second one is CH3 CH2 single bond CH double bond CH2. It is write this separately, C double bond C. This carbon one is hydrogen, one is CH3. This also one H, one CH3. This we write this C to H to H. To this CH2 CH3. If we compare the substitution, if we compare this with ethene, 4 hydrogens are attached. Now in this alkene, 2 hydrogens are substituted. One here substituted with methyl group, one here substituted with methyl group. If we compare this alkene, only 1 hydrogen is substituted with ethyl group. And hence this will be more substituted. alkene. And if let us assume that if there is formation of another product which has the structure like this, just let us consider if it is a structure like this. If we compare this and this will be the major product, because it is now more substituted than this also. If we compare this 1 and 2, this 2 will be more substituted in comparison to 1, and this will be the major product. In any type of this reaction, dehydration, when there is formation of multiple type of product, the major product will be the more substituted alkene will be the major product. Okay. And as this proceeds through intermediate formation mechanism or carbocation mechanism, intermediate formation, this intermediate also can undergo rearrangement. If you see one example, let us see one example. Let us see now. Okay. Let us see butanol. Butane 1-ol. This will have structure like CH3, CH2, OH. Okay. The step 1, this will undergo protonation and there will be formation of CH3, CH2, CH2, OH2. The next step, removal of water, minus H2, and there will be formation of CH3, CH2, CH2 plus. This one is primary carbocation. If you consider, let us assume we do some of the rearrangement and the primary carbocation is converted to secondary carbocation. Then the secondary carbocation will be more stable as compared to the primary carbocation. So if you see CH3, CH2, CH2, CH2 plus. If you shift one hydrogen along with its electrons, like one hydride, hydrogen along with its electron, if you shift this hydride to this carbon, we call this 1,2 hydride shift. 1 position, 2 position, from 2 position to 1 position. This is called 1,2 hydride shift. we shift this from here to here, there will be formation of CH3, CH2, CH, CH3 plus, and now this is a secondary carbocation. This secondary carbocation is comparatively more stable. This is comparatively more stable. Now this will undergo rearrangement and there will be formation of what? From this minus of H plus to form CH3, CH double bond CH, CH3. This is the measured product, which is Bug2ENE. Okay. If you see, let us consider any other example is given. I have done all the examples. Okay. Okay. Next, we'll do another example. That is formation of ethers from alcohol. Similar reaction, like to this similar reaction. We have studied this one, like CH3, CH2OH ethanol in presence of concentrated H2SO4 forms ethene plus H2. This is called dehydration of alcohol. But instead of this ethanol, if we provide excess of ethanol, like instead of normal, if we provide excess quantity of alcohol, instead of formation of alkene, this will form ether. CH3, CH2O, CH2, CH3. This will form ethoxy ether. I don't know, I'm not sure about the name. This will form ether. Ethoxyethane. Yeah. The name will be ethoxyethane. This will form ethoxyethane ether. Okay. Now what's the difference? The difference is mechanism. Let us see the mechanism for this formation of ether from alcohol. The same steps 1 and 2 continue similar. In the first step there will be protonation, formation of OH2 plus. Next step there is dehydration, formation of carbocation. Now there is difference. Instead of removal of one proton, this carbocation reacts with further alcohol. In this alcohol there is lone pair of electron. This lone pair of oxygen attacks as a nucleophile and there is formation of CH3, CH2, OH plus, CH2, CH3. Now this will lose one proton to form ether. Ethoxyethane. So if we use ethanol in excess quantity, instead of formation of alkene, it forms ether. Okay. Next we will see the formation of bisulfide or hydrogen sulfide. Bisulfide or hydrogen sulfide. If you have seen carbonate and bicarbonate, like if the group is CO3 2 minus, it is carbonate, and the group is HCO3 minus, it is bicarbonate, or we can say or hydrogen carbonate. So similarly, if the group is attached, that is SO4 minus, this is sulfate, and if the group is HSO4 minus, this is bisulfate or hydrogen sulfate. Okay, now we will see the formation of bisulfate from alcohol. If we react the alcohol with H2SO4 in heating condition like 380 degree Kelvin, like if we see, okay, alkene, this alkene reacts with H2SO4. And there in the previous one we have seen alcohol react with H2SO4 to form alkene. It undergoes dehydration to form alkene. Okay. Now if you see, if it reacts with H2SO4, but when it is heated, like RCH2 RCH2OH okay. RCH2OH, we cannot write this proper way. Let's consider another example. Okay. Sorry, let us consider this like CH3 CH2OH. If we react with H2SO4 380 Kelvin, or we can say heat, this produces CH3 CH2 HSO4, you can say ethyl hydrogen sulfide or ethyl bisulfide. How this will form? Let us see the mechanism. The first step is similar. First step, there will be protonation and there will be dehydration. CH3 CH2OH react with H plus to form CH3 CH2 OH2 plus, and next step there will be dehydration like CH3 CH2 plus. This is carbocation. Right. This another for next step can be followed in two steps. We can write like a simple one. This H2SO4 breaks as H plus and HSO4 minus. So this HSO4 minus can further attack and then formation of CH3 CH2 HSO4, or we can say if this is carbocation, this is carbocation, so this can also react with sulfuric acid as double bond OH. So lone pair of this oxygen can attack this, and there will be formation of CH3 CH2 OH plus sulfur double bond OH. Now this can use one H plus to produce CH3 CH2 HSO4 ethyl bisulfate, or we can say ethyl hydrogen sulfate. Okay, that's it for today. If any doubts, let me know in the comment section. See you in the next class.